Hi guys, this is your classmate Annabelle. So today is another stay at home day and also work from home day for me. So I thought it's also a nice day to do a video for CM4032. And I've been working for a jewelry company for more than a year now, mainly dealing with marketing and social media stuff. That's why I have my big camera here. And so I thought it would be nice to share with the class something that's related to my field of work and also related to chemistry. So what's related with chemistry, of course, are the gemstones. So today I'll be presenting the topic on the synthesis of artificial gemstones. Let's get started. Ever wonder why those gemstones and diamond rings are being priced so high in the jewelry stores? Let's look at the case of Titanic. Why the villain Carl in the movie of Titanic was trying so hard to get his tanzanite necklace back? What is so precious about the stone? It is very precious indeed. It was said that his necklace was priced at $20 million at that time. So, what exactly are gemstones and why are they so expensive? So basically, gemstones can be divided into two categories: precious and semi-precious. Today we are going to talk mainly about precious stones. Okay, I know they may look a little like infinity stones, but rest assured that they cannot do any harm to the universe. So firstly, we have every girl's best friend, diamond, following with the red colored ruby, and the beautiful ocean blue sapphire, and last but not least, the green emerald. So 4 of them are categorized as the precious stones. And these 4 stones were considered to be more valuable and rare in the past, and hence were named separately from the rest of the semi-precious stones. And next, let's take a peek into the history of artificial gemstones. Natural gemstones are highly prized due to their rareness, scarcity, and the rising cost of mining. In the middle of 19th century, chemical compositions of sapphire and ruby were unraveled, inspiring chemists to experiment on growing artificial crystals of these valuable gemstones. In 1885, a synthetic ruby known as the Geneva ruby influenced chemist Professor Vanouille to develop a film fusion process, aiming to produce high-quality ruby and sapphire. So what is the flame fusion process? In the flame fusion process shown here, crystal materials in the form of fine powder are fed into the flame produced by an oxygen-hydrogen burner. A conical pile is built up with the initial powder in which the hot particles sintered together to form a rigid sinter cone, shown here. Then the upper tip of the cone became molten. When the cone got sharp enough, new powder landing on the molten ball would melt and enlarge the crystal growth. With the uppermost skin of the growing crystal melted, the crystal would grow vertically, forming a single crystal known as a bowl. And the pedestal is lowered to keep the top of the crystal at the correct location in the flame. Now moving on, let's talk about some physical properties of gemstones such as corundum. Ruby and sapphire are the primary varieties of corundum, a crystalline form of aluminium oxide. It is a naturally transparent material but can be colored with traces of other metals such as iron, titanium, chromium, and vanadium. In the case of ruby, it is a combination of aluminium oxide with a little chromium oxide. So corundum is known as the third hardest natural mineral known to science. The hardest of corundum is attributed to its short and strong oxygen-aluminium bonds in the structure, shown in this figure. These bonds pull the oxygen and aluminium atoms close together, making the crystal hard and dense despite the fact that it is a blend of 2 relatively light elements. And one of the most crucial tests in identifying mineral specimens is the Mohs hardness test. This test is used to compare the resistance of a mineral to being scratched by 10 reference minerals known as the Mohs hardness scale. Corundum has a Mohs hardness of 9, which is exceptionally hard and tough. So today, with both natural and synthetic gemstones in the market, how can we differentiate them? In the figure shown here are the mix of synthetic and natural rubies. I personally can't differentiate them by just using my eyes, and even gemologists sometimes can't differentiate them. So in this case, we can use trace element chemistry, such as this machine here, EDXRF, which is known as the energy dispersive X-ray fluorescence, to identify the synthetic and natural gemstone. So for more information about this instrument, you can Google or ask me if you're interested. So I'll end here, and last but not least, I would like to show some pieces of jewelry from my jewelry store so that you can see the gemstones in real. Hi, I'm back. So I hope you enjoyed the short video just now. I tried to make it short, but I have so much to share. So now I would like to share with you some pieces from my store, my jewelry store. And for now, we have a sapphire. This is the sapphire ring, which is part of the corundum family that I've shared just now. It's the same family as ruby, but unfortunately I don't have a ruby to show you now. But we have another red stone, which is a spinel. Bling bling. Yes, it's a spinel. It's different from ruby, but they are very similar in color. And also sapphire, we also have other sapphire that is pink in color. Sapphire has a lot of color ranging from blue, pink, yellow, and green. Yeah, so it's very interesting. And last but not least, this is quartz. It's a rutilated quartz. It has these tiny golden needles inside the stones, which is due to some chemical reaction, like chemical inclusions. It's very pretty. Yep, I hope you enjoyed the video. That's the end. Bye.